Now we're going to look at checking linear systems by substitution. So we've already put a bit of background work into this. We've solved this. I'm about to sneeze, sorry. Excuse me. Thank you. We solved this already. We used elimination. So I'm going to jump back in our notes a little bit. Here it is. And we found that the point of intersection was -8 and 3. We went ahead and we graphed it, and our point of intersection was roughly -8 and 3. We misdrew the line a little, but that was pretty much what it was. And now we're doing our final step. We're going to check our answer here. So to check our answer, we obviously need to write that point of intersection, which we said was -8 and 3. Okay, so this is the x value and this is the y value. So you technically should only have to check once, but we're going to run through it twice just to show. And checking is substitution. It's a simpler form of substitution, which is a form that you use sometimes to solve linear equations, but we're going to check using it. So here's one way to set up. Our x value is -8. So in both equations, -8 will be replacing that variable. And our y value is 3, so in both equations, it will be replacing that variable. And then the left side should equal the right side. So let's test out equation number 1. -2 times, we'll write it in red, 8, plus 4 times 3 is equal to 28. So we're trying to prove that this being the left side is equal to the right side of the equation. So let's kind of run through this. -2 times -8 will give us 16. 4 times 3 is 12. Our right side is already 28. 16 and 12 is 28. So first equation checks out. Second equation, we've got a fraction, a little harder. 3 was our y value, so y was by itself on the left, is equal to -3 over 2 times the x value, which was -8. Minus, that's a much better looking 9. Okay, same concept. We need the left side to equal the right side of the equation. So we still have 3 on the left is equal to. So -8 times 3 is positive, and it's going to be positive 24 over 2. It's going to be 12. Yeah. 12 minus 9. 3 is equal to 12 minus 9 is 3. Checks out pretty nicely. So apparently the work we did in the other two questions, so we'll put them all side by side. The work we did in the graphing and the work we did in our algebra of elimination, so all worked out. Everything kind of panned out in this question. Whoops. There we go. Okay. So I just quickly graphed these here. The red line is exactly what we've shown, and the blue line is pretty much what we'd shown, and they intersect at -3 and 8. Now these coordinates, this is the only coordinate that runs through both of the same two lines. So when we check algebraically, it fulfills both. Both the left side and the right side will be equal. If you were to plug -14, 0 into the equation of the blue line, you would get two sides that aren't equal because it doesn't fall on the blue line. And vice versa, 0, 9, if you plug that coordinate into the red line, you would get two sides that aren't equal either because it's not on the red line. This is the only coordinate that suffices that no matter which of the equations you plug it into, the left side will equal the right side in that case.